This video is going to cover Section 1.7, targets 1.10 and 1.11, that you can combine and compose functions, and then also find the domain and range of combined and composed functions. So just to start out, I'd like to try a little warm-up just regarding domain on 3 different types of functions and see how well you do. You can just do this on the top of your notes or on a scratch sheet of paper. Pause the video and then come back and check your answers. So in number 1, and it's f of x equals x squared plus 3x minus 17. This is a quadratic function, and it's a parabola. And when thinking about domain, you want to think about, is there any x value that I can't square or any x value that I can't multiply by 3? And there isn't. You can multiply and square any number. So for this, the domain is just going to be all reals. In number 2, g of x is a rational function. It has some division in it, and there's one number we can't divide by, and that's 0. So we're limited by what we can plug in for x to make sure that we don't plug in a number that would make it 0. So for starting with the domain, take the denominator, make it so that it doesn't equal 0, and then solve for x. So I get x squared can't equal 49. I got to get x by itself, so take the square root of both sides. Then I'll get plus or minus square root of 49, which is plus or minus 7. So my domain can be any number except positive 7 or negative 7, because that would make the denominator 0. And in number 3, h of x equals the square root of 9x minus 27, I have a square root, and I'm limited by what I can take the square root of. I can't take the square root of a negative number. So I'm going to take what's underneath the square root and make it so that it is greater than or equal to 0, and then solve for x. And so when I do this, I get 9x minus 27 has to be greater than or equal to 0. Add 27 and then divide by 9, and you get that x has to be greater than or equal to 3. Any value less than 3 would make this negative. We can't take the square root of a negative number. So I want you to keep these in mind when we talk about combined and composed functions. So before we get to combined and composed functions, I want you to think about some functions that occur in your everyday life. So thinking about a vending machine, what's the domain and range of a vending machine? Or thinking about an ATM machine, what's the domain and range? There are functions all around us that have inputs and outputs. And the next example I'm going to show you is doing the laundry. So how many of you guys do the laundry at home? So first, let's just start with the washing machine. What is the domain and range of a washing machine? Well, if you've got your clothes, most likely they are dry, and then they are also dirty. So this is what you are putting into the washing machine. Then the machine does its job, and then what comes out of a washing machine, that would be the output or the range, is going to be wet, clean clothes. So thinking of the washing machine as its own function, you put in dry, dirty clothes, and what comes out, wet, clean clothes. The next part we have would be the dryer. So what is the domain and range of the dryer? Well, if you're doing a load of laundry, most likely you're putting in wet, clean clothes, and the output is going to be dry, clean clothes. So now when I compose these two functions together, the domain and range is going to be different than if these were two separate functions. Now my input is dry, dirty clothes, and my output is dry, clean clothes. So you'll notice that I don't have any wet, dirty, or wet, clean clothes in the domain or in range of this, but I did when I was doing the domain and range of the washing machine. So I took two separate functions, I composed them, so combined them together, and it makes a different domain and range. So we're going to use this with functions. So in combining functions, you should be able to add two functions together, subtract two functions, multiply two functions, and also divide two functions. So the formulas I'm just going to put right up. F plus g of x would just be adding f of x to g of x. F minus g is going to be f of x minus g of x. F times g, f of x times g of x, and then f divided by g will give me f of x divided by g of x. So here's an example. If we have f of x equal 2x minus 1 and g of x equals x squared plus x minus 2, I want you to add, subtract, multiply, and divide these. And I'm going to walk you through the answers, and then we'll do another one. So the first one is addition. So all I'm going to do is add my two functions together. And then I want to combine like terms. So I have a 2x that I'm going to add to an x. I have a negative 1 I'm going to add to a negative 2. And then x squared is all alone. And I'm going to put that in descending order of the exponents. And I get x squared plus 3x minus 3. In subtraction, now you'll notice that I did the addition in parentheses, and it's a good habit to get into because in subtraction, the second function you definitely want in parentheses because you can't forget that subtracting an entire function is like multiplying it by -1, and so we need to distribute that negative value. So when I do this, I'm going to have 2x minus 1 minus x squared minus x plus 2, and then when I combine like terms, I end up with -x squared plus x plus 1. In example C, we are multiplying the two together. Now you'll notice I am doing the box method. So if you take 2x minus 1 and write the terms along the side, and then the x squared plus x minus 2 along the top, and then multiply, so find the area of each box, and then combine like terms at the very end. So 2x and x squared makes 2x cubed. X and 2x makes 2x squared. -2 and 2x makes a -4x. Then we get -x squared, -x, and a +2. And when I combine like terms, I get 2x cubed. I'll have a +x squared, a -5x, and then a +2. I forgot to put this one part up here, and just showing that you're multiplying the two functions together. And then lastly is the division. And now I just realized that I have forgotten to do the domain. But so far with all of these, the domain is going to be all reals. It's the division that you have to be careful about because you can't divide by 0. So when I plug this in, f of x over g of x, this is as simplified as the function can go. You don't have to worry about simplifying it any further than this. And now when I'm focused on domain, I want to set the denominator equal to 0, or sorry, to not equal 0. And then I'm going to factor this. So use your diamond problems. So this factors to x minus 1 times x plus 2. That still can't equal 0. Now we've got 0 product property, so x minus 1 can't equal 0. So that means x can't be 1. Then I have x plus 2. Oops, x plus 2 can't equal 0, so then x can't equal the -2. Therefore, my domain is that x can't equal 1 or -2. So on the notes, I did say that you're supposed to state the domain for all of these. The only one that isn't all reals is going to be the division one because you can't divide by 0, and an x value of 1 and -2 would give a denominator of 0. So there's our domain. And don't worry about the range right now. Here is example 2. We have the square root of x plus 3 and the square root of x minus 2, and it says to evaluate the sum of these two functions and state the domain. So if you think about adding these two together, it's going to be the square root of x plus 3 plus the square root of x minus 2. I can't simplify that any further. That's as far as I can go. But when thinking about the domain, you want to think about the domain of each individual function and then what it would be as one function. So if I find the domain for f of x, I'm going to have x plus 3 has to be greater than or equal to 0. So I get x is greater than or equal to -3. The domain for the second part for g of x is x plus minus 2 has to be greater than or equal to 0, so x has to be greater than or equal to 2. So these are the domains of the functions separated from one another, but what would the domain be of the combined function? Well, I want to take the domain that is not going to give me any negative numbers in the in the square root. And so I'm going to have to take the domain as x is greater than 2, because if I do anything less than that, so if I do less than 2, so 1 or -3, it's going to make negative values under here, and I can't take the square root of a negative number. So my domain for my composed function has to be greater than 2. If I had 1, it wouldn't work. It would still give me a negative. If I had 0, it wouldn't work because it would still give me a negative here. So you have to take the domain of one of them so that it doesn't create any negative numbers underneath the square root. So this was combining functions. The next part we're going to talk about is composing functions. So let's say your local computer store is having a sale. The models that are on sale either cost $300 less than the regular price or are 15% off the regular price. Let's say X represents the computer's regular price, and the discounts can be described with the following functions. So I have f of x equals x minus 300. This represents the $300 discount. And then g of x is 0.85 times x. This represents a 15% discount. So just remember with percentages, When you have a discount, it's always 1 minus the discount to see what your multiplier is. This is just telling us that we have 85% of the cost left over. So then it says, at the store you bargained with the salesperson. The sale price will be 15% off the regular price, followed by a $300 reduction. So in terms of f and g, this offer can be obtained by taking the output of g of x and using it as the input. This is called composing functions. So I'm going to do my 15% discount first, and then I'm going to plug that into my second function, which is then take the $300 discount. So now what would it look like if we flipped that and I took the $300 discount first and then the 15% off? Well, now I'm going to switch these around, do the x minus 300 first, plug that into the next function, and then you get 0.85 times x minus 300. And it says, does the order of the discounts matter? Are you going to pay the same price? And the answer is no. So if you take a look at what we did first, in the last scenario, we took the 15% off and then the 300. In the second, we did the 300 off first and then took 15% off. And if after I distribute the 0.85, you'll notice that that number over here is less. I would rather do the 15% off and then minus the 300 rather than the other way around. So this is called composing functions. And there's some notation to look out for. So we have this notation, it's f of g. This is just a little circle. It kind of looks like it's an O for fog, but it's f of g of x, which can also be written as f of g of x with parentheses. If you use the parentheses, you work from the inside out, and then if you have the f with the little o, you work from right to left. So this is telling me that the output of g, I'm going to do the g function first. The output of g becomes the input of f. And then if I switch them around, it's g of f of x, or g of f of x in parentheses. This means the output of f becomes the input of g. So let's do a couple of examples. In this first example, I've added an a that is not on your note sheet, so we'll want to do this first. So we have an f of x and a g of x. It says evaluate and state the domain for both b and c. We don't have a domain for a. So g of f of 3. Since I've got the parentheses, I'm going to work from the inside out. This means I'm going to take 3, plug it into the f function. Whatever my answer is, I'm going to plug that into the g function. So when I do that, f of 3 comes out to be 5, and I'll plug that 5 into the g function, and I get 21. So g of f of 3 equals 21. And now you're going to be expected to do the same thing, but just with an x value. So this notation here is telling me I'm going to take x, plug it into the g function first, and then my output is going to be put into the f function. So it's the x squared minus 2x plus 6. When I do that, I plug that in, and you can just leave it as is. You don't have to distribute right now. And then for this, the domain is going to be all reals, since my output is a quadratic function. Then in example C, this I just flipped it around. Let's do the f function first, and then take that and plug that into the g function. And when I do that, you can do box method to simplify it and then combine like terms. And then at the end, you should end up with, where's my answer? It's not on here. Oh, I put it up here. 9x squared minus 30x plus 30. And then the domain for this, once again, it's another quadratic, is going to be all real numbers. And then the last example, example 2, we have f of x is a rational function, 2 over x minus 1, and then g of x is 5x plus 1. We want to evaluate and then state the domain of each. So in A, we are going to do the g function first, and then plug that into the f function. And when I do that, I get 2 over 5x plus 1 minus 5, or minus 1, simplify it to get 2 over 5x. So this is the composed function of f and g. And when I find the domain, remember we can't divide by 0, so what value of x would make that 0? It would be 0, so x cannot equal 0 in this case. And then if I flip it around and do the f function first and then plug into g, plug in and simplify it, I get 10 over x minus 1 and then plus 1. Well, I can't have a denominator of 0, so that would be x cannot equal a positive 1. So this video covered section 1.7, combining and composing functions, and also finding the domain of combined and composed functions, not the range. You don't have to worry about the range of these, just the domain.